Welcome to the demo session of my talk about workload memory protection. And in the next roughly 10 minutes, I will show you how to set up workload memory protection. And then I will put an SAP instance under memory pressure to demonstrate that it works. And then I will remove the protection to show that without it, the sub instance really would get into trouble. So I have here a slash for sub 15 SB2 system already prepared. Anything is set up already to save time, but let me quickly go through all the necessary steps. You can find in a more detailed form in the slash for sub guide on our documentation page at SUSECON. So it's in the official documentation. What I've done to set it up, first step was to install the SAP WMP package. I should install that. Install. So since I already done that, it will tell me now, yep, it is already installed. So the package is there. Next step would be to switch to C group 2. So for that, I added etc default grub, and at the line where the variable grub command line Linux default is defined, I have added here at the end systemd unified C group hierarchy equals true. This parameter will tell systemd to switch to the version 2 and not version 1. The last one here is the swap accounting I've put there for the demo purposes so that I can show you which amount of memory has been swapped out for each C group. For WMP, this is not necessary. So after editing the file, you have to rewrite the bootloader, as it says here at the top of the file, and afterwards we reboot the system. And if the system is back again, we can check if we have really C group 2 mounted. So let's grab for C group in the mounted file systems, and there we have it. sysfs C group is C group 2. Next step would be to edit the instance profile, because we have to add that program which is moving all of the SAP instance processes into the dedicated C group. This is a sub-slide, it's called. So we go to use our SAP. That's my set. It comes sys, then the profile directory, and there is the instance profile. And here, almost at the end of the file, there is this execute statement where the capture program is called. The capture program is part of the SAP WMP package, which I have installed earlier. So after editing the profile, I have to restart the entire instance so that the capture program is called and the processes are moved into the subslice. So how should it look like if we haven't forgotten anything? Let me check with the systemd-cgls program that shows all the processes and in which part of the C group hierarchy they are. So, and here we have the dedicated C group. It's called subslice. There it is. And below that we see a scope that's only for organizational purposes. And here is the substart process and the entire instance. So here, in my case, this is a one SAP HANA instance. So looks good. We have all the instance processes there where they should be. And the last step would be to set memory low, so the amount of memory the kernel should protect for that subslice. To do so, I use the command system control. Then there is set property. I want to set a property for the subslice, and my property is memory low. I have a 32 gig system here, and I can use the allocation limit, which I have tweaked a bit. So in my case, I know that my HANA system will not consume more than 29 gigabyte. So I use 29 gigabyte here as the value for memory low. So that's finally it. WMP is set up correctly and should work. I know there are a few steps to do that, and there is a certain risk that maybe you forget something. So in the latest SAP WMP package, which should be available at the time of the SUSECON, we have added a little script which is called WMP check, which will verify if everything is okay. And in my case, everything is green. So it checks if we really have C group 2 enabled. That is this line. It also checks if we have this entry for the capture program in my instance profile. Wonderful. Looks good. Here's the OK. All sub-instances contain the entry for the capture program. I only have one instance. Perfect. It says that memory low is set and in use, and that the subslice is also ready. And it also do some sanity checks for my memory low value, because of course it should be larger than the allocated memory of my instance, especially for HANA, that makes sense. And also that my memory low value is not too high, so too close to the total memory I have. So everything is fine. W have been set up correctly, and it should work as said before. So to create some pressure on the sub instance, I have two programs here. The first one will read a very large file from disk and therefore cause a massive increase of the page cache. This is one of the problems we have seen in the past, which can really affect an SAP system or cause an SAP system to be swapped out. And the second one, I have a program which is just allocating and using a great amount of memory, which also would cause memory pressure. So so that we can monitor that, I have here at the top of the screen a little program or little script which is updating itself every second. And what it does, that it will show for each of the major C groups. It would be the subslice. This is where our SAP instance is located. Then for all the user logins, I have the user slice. I have an init scope. I don't expect that will happen much because this is only system D. And here is the system slice, which is a slice where all the system services are present. So something like SSHD, like syslog, or any other service which is running on that system. And for each of the slice, I can show the memory low value. And of course, it makes sense in our case only for subslice. And here it is. These are the 29 gigs I have configured earlier with the system control set property command here. That's it. That caused this entry. Then I can here see the current used memory of each suite group. So my HANA instance, which is currently running, consumes 28 gig, or roughly 28 gig of memory, and the other slices, so merely 2017 63-bit. Nothing has been swapped out. This we can see here. And here a little bit more details. I have some statistic about the allocated anonymous memory, and here is the file cache, the page cache. And we see that the HANA with its 28 gig, almost anything is anonymous memory, and we have roughly 1 gigabyte of page cache. So when I start my memory pressure program, I will do this from the command line here. Well, the good question is where here in which C group I should see any changes. So this is a shell of a user login, so it should happen everything here in the user slice. Let's check that in which C group my shell currently is. There is an entry in the proc file system for that. It's called C group, and my shell and all my bash here and all the program I'm running are in session number 8, in the user slice of the root user ID 0, below user slice. So if I consume memory here, I should see this in this line. So this one we will watch during this the experiment, and of course we also keep an eye on the subslice. So let's do it. Clean the screen. And first I will call a program which is eating up a little bit of the page cache. So what's to expect? We have memory, we have workload memory protection in place. That I expect that here at the memory which the HANA is using, nothing should change or nothing big should change. Of course, the HANA is working in the background. And that's important. We should see no swapping here. So the subslice should be protected. Of course, we will see anything in the page cache in the user slice, because here's our program running and this is reading a file. And therefore, we should see an increase here. And because we causing a memory pressure here, I expect, of course, that swapping will occur, but the swapping should be either in the user slice, system slice, or the init scope, but never in subslice. Oh, let's start. It's running, and here we see the page cache of the user slice is going up, and we see, oh, it's starting to swapping, but our sub processes are not affected. Okay, the SAP HANA system is doing something, but there's no swapping and the memory is not going down rapidly. So that's done. The page cache pressure has finished. A little bit has been remained. There's roughly 1.2 gigabyte of page cache in the user slice, but our HANA is well and nothing has been swapped. Let's allocate 5 gig of memory. So that's the other form of memory pressure. And we see here it's allocating memory 2 gig, and we see massive swapping, but again, not in the subslice. There's anything is fine, still 28 gig of memory, nothing has been swapped out. The really pressure remains in user slice. My program, which is allocating 5 gig, is fighting against itself, because I think the 2 gig here of swapped out memory were part of that program. So we see that against both forms of memory pressure, WMP works. And okay, nice demo, but how can you be sure that if I disable WMP, everything would be fine as well? So let's disable it just simply by setting the protection to 0. So WMP, or the Linux kernel, with no protection, or will not protect any memory in the subslice. Here we see everything is 0. So let's start again. File the page cache. And here we see it's not good for the HANA. The memory is going down and the swapping has already been started. 130 megabyte, 580, it's going up. So we see the HANA or the sub instance gets swapped out. And let's also do the second form. Let's allocate 5 gigabyte of RAM. And we see, oh, that's not good. That's really not good for the HANA. 5 gigabyte have been allocated, and the HANA really lost memory and was swapped out. So I hope that shows that WMP in such scenarios really can be a protection. So, 15 minutes, longer than I expected. Thank you very much for your time, and I hope you are interested in WMP and it can be something good for you.